It was Yogi Berra who said, "No one goes there anymore. It's too crowded." In this lesson, we're going to state the difference between measures of central tendency and measures of dispersion. We're going to compute the range for a set of data. We're going to compute the mean deviation for a set of data. We'll compute the variance for a set of data, and we will compute the standard deviation for a set of data. All to answer the question, how do your entertainment expenses vary? Let's make sure we're ready for this lesson by taking a look at warm-up number 2. Given the following set of expenses, $7, $16.50, $12, $6.50, and $10, find the difference between the greatest and least expense. Well, the greatest expense is $16.50, and the least is $7. So just by subtracting, we get $9.50. Now, let's find the mean of the greatest and least expense. We already know that the greatest expense is $16.50 and that the least expense is $7. We're going to add those together and divide by 2 to get $11.75. Now what we're going to do is we're going to find the mean of the data set, which means we're just going to add all of these up. 7, $16.50, 12, $6.50, and 10, and divide that by the number of points that we have, which is 5. This is going to give us $10.40. Now we're going to take a look at a problem that you will be able to do by the end of this lesson, and that is to find the standard deviation for the following data set by filling in columns in the table using the formula and rounding to the nearest hundredth. The first thing we're going to do is build a table, and in the left column, we're going to put the number that is the data. Next, we're going to put x sub I minus x bar. The third column, we're going to do the second column squared. So in order to move forward, we need to be able to find what x bar is, which is the average of all of those points, 11, 13, 15, 28, and 30. Now, when we add them all up and we divide by the number of points we have, which is 5, we get 19.4. So 11 minus 19.4 is a negative 8.4. We do this with every single one of them, and we see all the way down at the bottom, we wind up with a 10.6 for 30 minus 19.4. Squaring these, we square negative 8.4 to get 70.56. And we're going to square every single one of these numbers as we move straight down. Now, with all of these numbers squared, we get to move on. The standard deviation is when we take the average of this entire column and we square root it. And just by simply using a calculator, we can get that the standard deviation is 7.96. As a teenager, entertainment expenses might comprise a large fraction of your discretionary expenses. Think of all the money Americans spend on entertainment. Think of the inexpensive items. Think of the expensive items. Downloading a song from the internet can cost less than $1, while admission to a sporting event or a rock concert for a family can cost several $100s. A diner can sell coffee at a fraction of the price at which a gourmet coffee shop sells it. There truly is a wide range of prices for any and all of our entertainment expenses. Consumers really need to prioritize and make choices to keep within their budget, since entertainment expenses can vary greatly and are always discretionary. We already learned the measure of central tendency from the lesson on discretionary and essential expenses. Now, let's state the difference between the measure of central tendency and the measure of dispersion. Measure of dispersion, also referred to as spread, are single numbers that are used to represent a range of a number in a given data set. The mean, median, and mode do not tell the whole story of the distribution. A frequency distribution does not include how spread out the scores are, but it sometimes is difficult to interpret the dispersion from a table since it has so many entries. There are several single statistics that summarize this dispersion of a distribution of data. Knowing the dispersion of the data set helps you describe it and look for patterns in how you spread your discretionary expenses. Now, let's compute the range for a data set. Ms. Mady's video production club has 10 students in it. On the first day the club meets, she asks the members how many movies they streamed last year. The 10 students reported these numbers. What is the difference between the highest and the lowest number? The difference between the highest and the lowest of the distribution is called the range. The range is never negative and can only be 0 if all numbers are the same. Be careful, the data may not be in numerical order. The lowest and highest numbers are not always at the left and right ends of the lists, respectively. Using subscripts, you can let x sub high represent the highest number and x sub low represent the lowest number. The range is found by subtraction. So range is equal to x sub high, or the highest value, which in this case is 41, minus x sub low, or the lowest value, in this case 9, meaning that the range itself is 32. Let's check your understanding and find the range of the following data set. So range being x sub high minus x sub low means we're going to be taking a look at 68, which is the high number, subtracting 8, which is the low number, so that the range is 60. Let's extend your understanding and look at how the range of distribution could be changed if the number 4 was entered incorrectly and was actually 43. So the range being the high number, which is 68, just like it was before, minus the low number, 8, which is the same that it was before. So the range is 60 unchanged. Now let's compute the mean deviation for a data set. Maria, a video club member, noticed the range seems to ignore all the numbers except the highest and the lowest. She thought a better measure of dispersion would be to take an average of how far each number is from the mean. So how far, on average, is every entry in the data set from the mean of the distribution? The average of how far each number is from the mean is called the mean deviation. So we need to find what the average is. We can add up all of the numbers and divide by 10, but we could also do this in a spreadsheet. To do this, we build a table that has all of the data points in the left column. And in the B12 cell, we're going to put average equal B2 colon B12 and hit enter. So the average, or X bar, is 23. Now what we want to do is we want to subtract that from each of the data points. So in the cell C2, we want to put equal B2 minus $B$12 and hit equals. We can copy that and paste it into all of the cells underneath. In the C12 cell, you can see that there is a 0. That is where I added up all of those numbers. And ideally, you would like to see a 0 or as close to 0 as you can get. To square all of those data points, all we're going to do is up in the D2, we're going to put equals C2 up arrow 2. Then copy that and paste it into the cells underneath. As a formula, that would be represented like you can see here. It's saying how far is x sub 1 from x bar, and it should be an average same as x sub 2 was from x bar. So in D13, all I did was put equal average, open parenthesis, D2 colon D11, close parenthesis, and hit equals. We can see that what we get is 76.6. Let's check our understanding of this and show the mean deviation for the following data set is 0. The absolute value of a number is its positive distance from 0. The mean absolute deviation is a statistics that takes the absolute value of each number's deviation from the mean and average those absolute values. The 5 deviations from the mean. So if we average to find x bar, all of the data points, we get 35.4 is x bar. The 5 deviations from the mean are negative 27.4, negative 23.4, negative 1.4, 19.6, and 32.6. To find this, we add up all of those numbers and then divide by the number of data points. And we find that we get a 0, which is an optimal situation. Let's extend our understanding of this. The mean absolute deviation requires the use of absolute value, which is more cumbersome for mathematicians to make calculations with. So it is not often used as a measure of dispersion. The negative and positive deviations used to compute the mean deviation cancel each other out. To eliminate these problems, statisticians square each deviation from the mean and find the average of these squared deviations. The resulting statistic is called variance. The variance, denoted by this funny little symbol squared, a small sigma squared, can be shown algebraically using sigma notation, as you can see here. The variance is very commonly used to measure dispersion. The mean of this is 35.4. The 5 absolute value deviations from X bar are 27.4, 23.4, 1.4, 19.6, and 32.6. The sum of these deviations is 104.4, so dividing by 5 gives a mean absolute deviation of 20.88. The absolute value of a number is a positive distance from 0. The mean absolute deviation is a statistic that takes the absolute value of each number's deviation from the mean and average those absolute values. The mean absolute deviation requires the use of absolute value, which is more cumbersome for mathematicians to make calculations with, so it's not often used as a measure of dispersion. The negative and positive deviations used to compute the mean deviation cancel each other out. To eliminate these problems, statisticians square each deviation from the mean and find the average of the squared deviations. The resulting statistics is called variance. The variance, denoted sigma squared, can be shown algebraically using sigma notation seen here. Picture down. The variance is very commonly used to measure dispersion. Now let's compute variance from a data set. Find the variance for the data on the video production class. Ms. Mady's video production club has 10 students in it. On the first day the club met, she asked the members how many movies they streamed last year. The 10 students reported these numbers. It is a good idea to use a table to organize your computations. The mean deviation table from the last example needed an extra column for the squared deviations, and the last row shows the sum of each column. We go to find X bar, which is the average of all of the data sets, by adding them all up and dividing by 10 to get 23. So 32 minus 23 would be 9. Having done all of that, we add up this column to see if we wind up with a 0 in its place, which shows an optimal result. We then go and square each of those numbers. Now we need to know the sum of this whole column. When we add this all up, we're going to get a 766, and the number of entries is 10. So we get to do 766 divided by 10 to get 76.6. Let's extend your understanding and check cell phones morphed from a discretionary expense to an essential expense over the past few decades. The following data set shows the number of new cell phones owned by students at Cold Springs High School during the first 5 months of the new school year. Find the variance for the data set and round to the nearest hundredth. The first thing we're going to do is build a table and put all of those data points in the X sub I column. And we're going to add this up for the sum. That sum is going to help us find X bar, which would be 97 divided by 5, because there's 5 entries, to give us 19.4 as X bar. Now we're going to take the data point minus X bar. So 11 minus 19.4 is negative 8.4. And we'll do that with every single one of the entries, then add them up to see if we get a 0, which is an optimal result there. In the third column, we're going to do X sub I minus X bar squared, or really, it's that number we just found squared. So 8.4 squared is 70.56. We'll do that to all of them until we get to the last, to where we can see that gives us 112.36. Now we need to know what the sum of this whole column is, and we've just written it in sigma notation here. We can see when we add this all up, we get 317.2, and there are still 5 entries. So we're going to get 317.2 divided by 5, or 63.44. Now we're going to talk a little bit about some standard deviation. And since the variance square of the deviations from the mean, the units of variance must also be squared. So if a problem's original units are hours, the units of the variance are hours squared. If the units are movies, the units are movies squared. If a units are dollars, the units of the variance are dollars squared. These squared measures don't make any sense. To measure dispersion using the original units of the problems, statisticians make the square root of the variance to form a measure of dispersion called standard deviation. The standard deviation is probably the most commonly used measure of dispersion. Now let's compute the standard deviation from a set of data. Let's find the standard deviation from the data in the original problem. And we can do this on an Excel spreadsheet. After having built a problem and put all the data points in the X column, down in the B12, we're simply going to put equals average, open parenthesis, B2 colon B12, close parenthesis. Then in the C2 cell, we're going to put equal B2 minus $B $12 equals. We can copy and paste that into all of the cells beneath it. And then to see if our data is working well, in the C13 cell, we will put equals sum, open parenthesis, B2 colon B12. Then to see if all of our calculations are working at this point, in the C13 box, we will put equal sum, open parenthesis, B2 colon B12, close parenthesis, equals. We can see that we have a 0 here, so things are working optimally at the moment. To square that set of data in the D2 cell, we're going to put equal C2 up arrow 2 and hit enter. Then copy and paste that formula into the cells beneath it. In the D14, we're going to want to figure out what the average of this is by putting equal average, open parenthesis, D2 colon D11, close parenthesis, and hit equals. And we can see 76.6. In D15, what we're going to do for the standard deviation is we're going to hit equals SQRT, open parenthesis, D14, close parenthesis, and hit enter. So we can see that the standard deviation is 8.75. Now let's check your understanding and find the standard deviation for the following data set by filling in the columns in the table using the formula and round to the nearest hundredth. The table is built and all of the data points are put. In the B7, we put equal average, open parenthesis, B2 colon B6, close parenthesis, and hit equals for X bar to be 19. Now to find X sub I minus X bar. In the C2 cell, we are going to put equal B2 minus $B $7 and hit equals. We're going to copy and paste that all the way down. And then in the C8, we're going to check that our data is going well and simply sum that all up by putting equal sum C2 colon C6. To square that in the D2, we're going to simply put equal C2 up arrow 2, hit enter, copy and paste that to the cells beneath. We find the variance by averaging all of those numbers in the D9 spot by simply putting equal average, open parenthesis, D2 colon D6, close parenthesis, and hit equals. Now we need to find the standard deviation of this, which we will do in D10 by simply putting equals SQRT, open parenthesis, D9, close parenthesis, and equal to get the standard deviation is 7.96. Pizza is a very popular discretionary expense for high school students. The table here shows the number of times 80 seniors at Smithtown High School visited Smithtown Pizza Pals in August. Find the standard deviation and round to the nearest hundredth. Since there are more than one senior at a given number of visits, you need to take the frequency into account. So when we do this, we can see 5 times 12 is 60, 10 times 21 is 210, and so on. Now our total of that becomes 960, and there were 80 total, so X bar itself becomes 12. Now we're dealing with the original data number as X sub I minus X bar, so 5 minus 12 is negative 7. And we do that for each one of those entries. We square them, and then we go ahead and multiply that squared number by the frequency that had occurred. So 49 times 12 is 588. And this column winds up with a total of 1134. So the sum of that column being 1134 divided by 80, but that squared means we can go ahead and take the square root of it to get the square root of 1134 divided by 80, meaning that what we get is approximately 3.76. Let's check your understanding and look at the donations to charity that are discretionary expenses. In a class of 30 students, 6 students donated $5 each to Raylan for Life. 15 students donated $10 each, and 9 students donated $20 each. Find the standard deviation for this distribution and round to the nearest hundredth. Now, the number of students that donated the X sub I are 5, 10, and 20. We need to find the frequency of that. So 5 times 6 is 30, 15 times 10 is 150, and 9 times 20 is 180. Adding all of that up, we get 360. Now, we want this so we can find X bar, which is 360 divided by 30, which is 12. Now that we know that X bar is 12, we can say 5 minus 12 is negative 7. 10 minus 12 is negative 2, and 20 minus 12 is 8. Squaring those numbers to get 49, 4, and 64. Multiplying that number by the frequency, so 49 times 6 would be 294, 4 times 15 would be 60, and 64 times 9 would be 576. We do want the sum of that number, which is 930, because what we want to do is find the square root of 930 divided by 30, meaning we get approximately 5.57. Now, let's extend our understanding and say you learned that the mean deviation of any distribution is always 0. Explain why the X sub I minus X bar column in this table does not add up to 0. So I guess the first thing we should do is add up all of these numbers, and we come up with the number 2, and have to ask ourselves why. Well, this column does not incorporate the frequency of each entry. Using that column would be making the assumption that there were only 6 pieces of data, when in fact there were 80.